Hello everyone, this is my Lab 1 report on charge tapes. The purpose of this lab was to explore the physical properties of electric charge. Specifically, we wanted to determine the amount of excess charge on a single piece of clear tape. So as you can see in the image here, we achieved this by creating a scenario when one piece of tape levitates under another. By observing this interaction, we can measure the forces at play and calculate the number of excess electrons. So I used empirical analysis to observe how the tape interacts with other objects, and I use glow script to simulate forces. Alright, fundamental physics principles. So this lab, we're essentially balancing two invisible forces, so we have to rely on these three concepts. First is Newton's second law, which is force equals mass times acceleration, we know that. Second, Coulomb's law, which allows us to calculate the electric force between 2 point charges. And finally, force of gravity, which is constantly acting on our floating tape. Okay, so for the experiment, we stuck a base piece of tape to the table, placed another strip on top, and I ripped it off so it would acquire charge. To test the charge, I rubbed a plastic pen on my hair in order to give that plastic pen a negative charge. So when the charged tape, we don't know the charge on the tape, so when the charged tape and the plastic were brought together, they attracted. And we already know that the plastic was negatively charged, so the tape must have been positive. And all of this I calculated or measured, and I got those initial conditions. So for the main experiment, we ripped off two pieces of tape so that they both roughly had the same amount of charge. We suspended one of the tapes across two supports and then took another tape and held it under the supported tape, causing it to repel, as you can see in this image. Since the top tape is levitating, meaning it has zero velocity and zero acceleration, we know that now the system's in equilibrium. So this means that the electric force pushing up must be equal, and it must be exactly equal in magnitude to the gravitational force pulling it down. And this is the key to solving for the charge. And the distance we saw of this levitating was 1.7 centimeters, so 0.017 meters. So here, remember we said the magnitude of the gravity, force of gravity is equal to the magnitude of the electric force. So using the mass and the gravity, we calculated this, and we just solved for Q pretty much. And then to count the amount of electrons lost, and it's the amount of electrons lost because the tape is positively charged. We just get Q and divided by E, or well, protons, to get this. So now, glow script. So it's just my constants, initial conditions, and I pretty much just simulated the tape again. It's getting the force acting on it is gravity. So I have the gravity vector, and it prints a statement on what the force was, and then after that, I got the electric force and calculated the electric force just to verify that the magnitudes are equal. And then finally, we calculated the electrons lost. And so these are my results. As we can see, the gravitational force is equal in magnitude, opposite in direction, but equal in magnitude. Tape's charge was this, and this many electrons were lost. And this is pretty similar to my results from the paper. So the main ones to look out for: this Q, then that's right here, and this one right here. Pretty similar numbers, but obviously there's some errors, and we're going to talk about that. So model assumptions and errors. So to make these calculations possible, we had to make some simplifying assumptions. We ignored air resistance, and I think that was valid because the tape wasn't even moving. Second, and most importantly, we treated the long piece of tape as a point charge with all the charge concentrated at the center, but realistically it would have been spread out across the tape. And third, we assumed that both tape A and B had the exact same amount of charge as they were created using the same method. But most of those are not the case in the real world. It's much more complicated to calculate this. And so for errors, the first error was that there was probably a lot of charge leakage caused by handling the charged tape, and also measurement errors. Like we had to eyeball the distance it was levitating, and that's probably, that has to be imprecise. What if? So what if question is, what if the electrons had positive charge and protons had negative charge? So like inverse charges. All the empirical observations that we made will remain the same because of the phenomenon that likes repel and opposites attract. So nothing would have really changed. Why is it important to handle the charged tapes as little as possible? This comes with the concept of grounding. Our bodies are conductive, so when our skin touches the tape, we essentially provide a path for the excess charge to flow from the tape through us down to the earth. And so touching the tape like neutralizes it pretty much. And if we handle it too much, it's just going to lose all its charge. The electric force disappears, and experiments, it won't work. All right, thank you.